Good morning, students. So today we're going to solve question 3 from GATE CSE 2022. The question states that if r is the root of the equation, this is a quadratic equation, quadratic because its degree is 2, right? So now if it is the quadratic equation and its root is r, so that basically means that r can take two values, right? R can take two values, and we have to find those values, but it can take two values. That is the basic understanding regarding quadratic equations. Or any polynomial equation, that the number of variable values that the variable can take is basically equal to the degree of that particular equation, right? So that part we have. Okay, then we have to find the value for the expression, this thing, right? So we have to find the value for this thing. Now I will find the solution for this directly, but using tactics, because directly if I were to find the values and then apply into this, there is some complexity to that and some needless effort that you would be applying if you were to do it that way. Okay, so simply if this is the equation and this is basically this is the standard formula for finding the solution for a quadratic equation. If this is a quadratic equation, a, b and c can take any real values, then the result of that quadratic equation would be this thing, right? I applied this result that we have to this. We get x is equals to basically this expression. Simplifying it further, you basically get x is equals to -1 plus minus iota root 5, right? So it takes on an imaginary value, right? It takes on an imaginary value, and it takes not just one but two different values, right? So as I already told, it can have two solutions, and it does have two solutions. But the problem over here is that playing with complex number, manipulating complex numbers requires a lot of effort, a lot of steps, right? If you were to apply, if you say there are two variables, right? If you were to apply one of the values into this and then try to find it that way, it is going to take you enormous amount of time. And because there are two values of present, from one value that you solve this whole expression and come to a result, that answer that you may get may not match any of the options given, because the options are taken from the second kind of value which this variable can take, right? I hope that you must have understood that, because I will, if you're not, I will give a simple example for that, right? So this can take two values, right? And this kind of polynomial expression I represented by the function f of r, right? So so two values of r can be fed into this. The resultant would not be equal, could not be equal. They may be equal generally, but normally functions, when they are applied, they need not be equal, right? That is the fundamental meaning that is present with the definition of functions, right? So we have g of r is equal, so this is a simple example that I took with g of r is equal to some r square, right? And in this kind of expression, I applied the two different values and got to the different results, right? This expression is not equal to this expression because the sign is different. Hence the resultant was this, right? If it does not apply with your r square, why would it apply to this whole thing? In general, it does not, right? Now let's try to find a better way, right? What is a better way? So what all information do you have? With this expression you found the solution, and from that you try to solve, right? But this polynomial equation that you have, this quadratic equation that you have, can itself be used to simplify this. Why? Because if you multiply two of them, it will give you a quadratic expression also. If you multiply both of these, it will give you a quadratic equation also, and that quadratic equation can be directly simplified by using at least the degree 2 part. The r square part of it can be removed by using this equation. Why? Suppose that your r square plus 2r plus 6 is equals to 0. R is the root of this equation, right? So this r will follow this, right? Very good. So r square can directly be equated as negative of 2 of r plus 6, right? So whatever quadratic equation this multiplication of these two results into, I can from that remove the r square part, reducing the quadratic expression into a linear one, and two linear ones again multiplied would give me another quadratic equation. I can simplify that also, and then I will get a linear one again. And in that linear one, I can directly apply this value, and then in that simplified domain, I will directly get two different answers which are required. Any one of them will match one of the solutions, right? That is what I try to explain. The whole thing is, if you did not understood this, please rewind this video, because I have very systematically, in a very straightforward manner, said the whole thing over here, right? So let's do that. Let's do that, right? So this is your expression and this is your given part, right? So now if I were to multiply this with this, what will I get? Using this identity that we have, you will get r square plus 5 of r, because 2 plus 3 is 5, plus 6 whole times. Now I am going to multiply this with this, right? I get what? R square plus 9r plus 20, right? This can be written as r square plus 2r plus 6 plus 3r, right? And this can be written as r square plus 2r plus 6 plus 7r plus 14, right? And because of this given part, I can directly say that this portion will be equal to 0 and this portion will be equal to 0. Direct application of an equation that we have, right? We get, what do we get? We get 3r times 7r plus 14. Taking 7 common from this, what do I get? 3 times 7 times r plus 2, right? If I were to multiply this r and take it inside, what will that become, right? 21 times r square plus 2r, right? I get this. Now how can I apply this again over here? I can simply do it like this. I will basically add a 6 and subtract a 6, right? Now look at this. This part can directly be equated to 0, and the resultant part, after removing this, there is not going to be any r, right? Because there is not going to be any r, the result is not going to have two different values as was present with r square in this example, right? As I said, it need not be equal, but in this particular case, because the way they have formed the question, they seem to be equal, right? So if I were to remove this part, what do I get? I get 21 times 6 and not the 6, negative 6. So what does that becomes? 6 to 1, negative. Is there any option that matches this quantity? Let's see. Yeah, option D directly matches this quantity, and hence that is our answer, right? Very simple question, but requires a bit of practice in your arithmetic, because you are applying some tricks over here, right? It's not that directly direct forward, right? I hope you learned something, and have a good day.